Hello student, welcome to VidyaNest again. You are very much aware that we are going through permutation and combination where student and maximum students get fumble because this chapter actually demands the logical reasoning of the students. See, last day where did I leave? Where did I terminate? That if just recall in short span in different things to be distributed in identical things. In identical things to be distributed in R different groups where blanks allowed. In what manner? In what ways? In n plus r minus 1 c r minus 1 ways. And if blank not allowed, then n minus r c minus r ways in identical things to be distributed in different groups. This we are taught last day. And we did one sum based on this. I am just reminding you another sum of same type using this property, because this property concept is not confined in your board book. It is totally part and parcel of JEE level. And see, sometimes if the jugglery of sentence or words distracted us, that's why we cannot catch the theorem. And sometimes we cannot, if you can't catch the theorem, you cannot apply the same in a relevant sum based on this. So let us do one or two sums based on this theorem, because this theorem in OpenEye it seems very simple, but if you can't frame the equation, then it becomes tough. Let's do one sum based on this. The number of integral solutions of the equation dx is equal to 24. So this is one equation given, and non-negative integral solution means all solutions will be of this form, greater than equal to 0. Okay. Now let's start. 3x plus y plus z is equal to 24. See, non-negative solutions means x cannot be lesser than 0. That does mean y greater than equal to 0, x greater than equal to 0, z greater than is equal to 0. Now I am letting x is equal to k. Once you get x is equal to k, this equation turned into 3k plus y plus z is equal to 24. That means y plus z is equal to 24 minus 3k. Simple approach that is. And based on our basic perception, I can write 24 is obviously greater than 24 minus k. Okay, I can, if k is 0, it will be equal. In other case, 24 is always greater than 24 minus k. Yes or no? Yes. 24 is always greater than 24 minus k. Now 24 minus k, and if k is 0, it will be 24. And what is given here? Non-negative integral solution. So these must be greater than equal to 0. Non-negative. So I will eradicate the negativity. So the 24 minus k itself is greater than equal to 0. So this inequation gives us what? 24 minus k greater than equal to 0. That means 24 minus 3k. It was 3k. It is my mistake. 24 minus 3k. Just it needs rectification. So 24 greater than equal to 3k. What does that means? 8 greater than equal to k. That means k less than equal to 8. Okay? K less than equal to 8. Now you observe carefully. According to this formula, that is, this 24 minus 2k will be distributed into two groups, y and z. So this is n, and that two groups will be considered as r. So the formula is n plus r minus 1, c r minus 1. Therefore, that 24 minus 3k will be distributed into two groups, y and z. So number of solution will be what? N plus r minus 1. We observe n plus r minus 1. R is 2. 24 minus 3k, 2 minus 1, c, 2 minus 1. What does it mean? 24 plus 2, 26. That is 25 minus 3k, c1. Using the rule of NCR, we know NC1 is n itself. So 24 minus 3k is 25 minus 3k c1 means 25 minus 3k itself. Okay? Okay. Now, this is number of solution in terms of k. But what is the numerical value of k? How can I find k? Here, the semblance is given. K less than 8, greater than 0. So, I will choose k from 0 to 8 times. So, total number of solution, this will recur or this will repeat from 0 to 8 times. So, you can write total number of solution not in terms of k. Now, k will be calculated summation of, this is number of solution in terms of k. Now, for k 0 to 8, I will find the summation of this. K 0 to 8, 25 minus 3k. So, once you get summation, then what formula will be reminded? Sum of n natural number, or in AP you are taught sum of n natural number. You see, if I remove this summation, this 25 will repeat 8 times. 25, see, if I put 0, 9 times. 25 will repeat 9 times. Okay, K0, then also 25, K1, then also 25, K2, then also 25, up to K8, then also 25. And here also you see 3, 0, 1, 2, up to 8. That means 9 into 25 is 225. And here sum of 8 natural number. 8 plus 1 by 2. So, 225, cancel it, 4 minus 36. 3 into 4, 12, 108. Answer is 117. So, in short span, let us go through what we have done. This is the, uh, permutation combination chapter. Last day we had left at this concept that n identical things are to be distributed in r different groups where blank space allowed. In what ways? How many ways? N plus r minus 1, c r minus 1 ways. But if blank is not allowed, then in how many ways we can distribute n identical things? N minus r 1, c r minus 1 ways. If you forget the propagation of this theorem, you can see the last day's video. Now, based on this, one sum we did last day, it came in alternative here in JE. So, it is important for JE and obviously important of formation of basic perception and grip on permutation combination. So, this is find the number of non-negative integral solution of this equation. See how did I start? A non-negative means each term must not be less than 0. If any term is not less than 0, then they must be greater than equal to 0. So, I will let x greater than equal to 0, y greater than equal to 0, z greater than equal to 0. Now, I will let x is equal to k. Once you get x is equal to k, then that equation will be turned into two variable y plus z 24 minus 3k. Now, how I can relate this result to that theorem? Here, number of things were n. Here, number of things 24 minus 3k, and these number of things are being distributed among two groups. In what way? N plus r minus 1. Here what is n? Here this is n. N plus r minus 1. N plus r minus 1 C r minus 1. So it will attain the form NCR. NC1, I have just told you that NC1, if you calculate NCR using the formula, you will get NC1 is equal to N only. NC1 is equal to N only. So number of solution in terms of K will be 25 minus 3K. But here you observe, with our basic knowledge in number system, we can say 24 greater than equal to 24 minus 3K. Why? Because if K is equal to 0, then there will be the possibility of equality, but keep on increasing the value of K. 24 always be greater than 24 minus 3K, and that thing always be greater than equal to 0, because that is non-negative integral solution we are told to find. Once you get 24 minus 3K greater than equal to 0, by calculation we have got K less than equal to 8 and obviously greater than equal to 0. Now that number of solution in terms of K will be propagated from 0 to 8. Okay, because if I put 0, then also 25 by 3K. In that case, I will put 25 minus 3 into 0. Okay, then if I put 1, 25 minus 3 into 1, then 2, 25 minus 3 into 2. So keep on putting the values of K. You will get 25, you will get 9 times. 25 will get 9 times, and other terms, if I take K 3 common, it will remind you sum of a natural number in AP. So by calculation, we have got answer 170. Now let us see if student had to face any problem in JEE in yesterday years or not. Let's see. In recent past, 2024, one sum came based on this. JEE Main 2024. The number of ways (21) identical things distributed in joint. It came JEE, it came apple. So no point of changing that. (21) apples can be distributed among 3 children so that each children at least 2 apples. Option A, option B, Option D 1, 3, 6. So these are 4 options. So if you deeply analyze the language of this question, you can find the relation of that theorem to this sum. See, total total number of apples 21 and 3 children. Children will be denoted by, say, X, Y, Z, 3 children. Now, each children will get at least 2 apples. It can be more. So, we can let X is equal to 2 plus a new variable U. 2 plus new variable U. Minimum 2, maximum we don't know. Then Y is equal to, that is in case of Y also, 2 plus V, and Z 2 plus W. If you can ask me, okay, you are taking 2 plus U. If they get exactly 2 apple, then Y U will be 0. So what will be the criteria of U? 0 or greater than 0. If Y gets exactly 2 apple, then what will be the role of V? V will be 0. More than 2, greater than 0. So V also have that criteria. And same will be done with W. Hope you can get the condition is so formed. Okay. Now, 3 students, three children are getting 21 apple. So how to frame the equation? X plus Y plus Z is equal to 21. The sum when came, maximum students started from here and took X greater than equal to 2, Y greater than equal to 2, Z greater than equal to 2. Answer came option A. But that was not wrong. A twisting is given in the sum. Here we have seen, we have taken in proper order 2 plus U. If they get exactly 2, UVW will be initialized by 0. Otherwise, it will be increased. Now, in place of X, what I should put? What I should put in a place of X? 2 plus U. In place of Y, 2 plus V. In place of Z, 2 plus W. Two, 2 plus W. That is 21. So gradually we are tending to the conclusion. So 2 plus 2 plus 2 will be 6. U plus V plus W is equal to 21 minus 6, that is 15. So once you get U plus V plus W is equal to 15, then what I can comprehend? Total number 15 are distributed into 3 groups. So that formula will be recalled. That formula, n plus r minus 1, cr minus 1. See, n identical things are distributed in r different groups. So Total number, what the answer is, the question, what is the question? The number of ways, total number of ways. Therefore, here u greater than 0, v greater than 0, w greater than 0. So, total number of ways n 15 plus r 3 groups, 3 minus 1 c 3 minus 1, 15 plus 3, what is that? 18, 18, 17 c2, 17 c2. Does it match with any option? Let us put it in the formula. Factorial 17, 17 minus 2 factorial into factorial 2, factorial 15 into 2, factorial 15 into factorial 2. So 17 into 16 by 2. Answer 136, option D. Option D. So this is straight joint level approach. Unless and until you cannot catch this formula, hardly you can defend this type of straightforward question. Question is has straight approach. But if I don't know the approach with proper language, if I can't comprehend, hardly I can define an example. Okay? Hope you have understood. Now, suppose there are n different things, n different things to be distributed in r different groups. N different things are different groups. Suppose theoretically, if we can't catch, let us take example with 3-4 terms. Suppose 4 different things, 1, 2, 3, 4, and 4 places, 3 places. Now, how many ways I can distribute these 4 different things in 3 places, 3 different places where blank space can occupy, blank space can come. Then you observe, carefully you observe, see, total number of elements are 4. Yes or no? Yes. So, I can, let us choose this star. Where shall I put? Either in this place, or in this place, or in this place. Yes or no? So, first star can be placed in 3 ways. Now, skip to the circle. Circle is also a thing. Means, sarcastically I have taken, symbolize the things. Now, this circle will be placed in these 3 places. How many ways? Here it can come. Yes, here it can come. Here it can come into 3 ways. The delta triangle also 3 ways. And that square also in 3 ways. So 3 to the power 4 ways. Yes or no? So in this way, in different things, if I distribute in R groups, in what manner? Not n to the power R, R to the power n ways. Yes or no? Now we'll come to the topic. Now, in this topic will remind you few basic property of set theory. What property of set theory we are taught? Say n A union B whole complement. What is that? N A complement intersection B complement.
Yes.
Then N A complement intersection B complement intersection C complement. By De Morgan's law, I can write N A union B union C whole complement. What does it mean? It means NS, S stands for universal set minus this. Now, how to open this? We know NA union B. NA plus NB minus NA intersection B. Then what about the with the three sets? That is NS. Now NA plus NB plus NC minus NA intersection B, NB intersection A, NC intersection A plus N A intersection B intersection C. Hope you can remember these basic level formula of set theory. So, more revised form is, if more than 3 sets are given, how long will you proceed? Better you write in terms of summation. See, you can write NAI minus, you can write summation NAI intersection AK, again plus, means you are taking in thrice, AI, AK, AJ and so on. Understand? That is recurrence formula in set theory you are taught. Understand? Now, this topic actually will be the conjunction of all these concept. R to the power n wala concept you have understood properly. That is good, and then you can defend this theorem. Let us discuss the theorem. If n different things to be distributed, if n different things to be distributed in R different groups, if lengths not allowed, then total number of ways. So this is the topic now, one of the most important topic in permutation combination.
Okay.
So there are n different things and are different groups. 1, 2, 3 up to R. Let us denote the group groups by G1, G2, G3, GR. These represent the group. Okay. If with that example which we have few minutes back recalled, that if four different things are to be distributed in three different groups in 3 to the power 4 ways, then n different things to be distributed n different things to be distributed among r different groups in r to the power n ways. That is, but that is not the working rule. That is the total, total distribution. That is called, in terms of set, universal set. Okay. That is total distribution. Total distribution where blanks allowed anywhere. Blanks allowed anywhere. There is no such condition. Anywhere blank space can allow. But now I will specify. You see that example which the example few minutes back we have gone through this example, 3 to the power 4. In this way, suppose there are 5 objects and 3 places. The total arrangement is what? 3 to the power 5? Yes or no? Already.
Yes.
Where blank space can come anywhere. Now, if I specify, oh, this is 4 to the power 5, sorry. This is 4 to the power 5. Because 4 places. Now, I am crossing this. What is meant? I am specifying that this place will remain blank. Then it will be 4 minus 1 to the power 5. Yes or no? If I cross another space for blank, then 4 minus 2 to the power 5 number of arrangements. So this condition we have to understand. So if you can catch the concept, I am telling you, you will be few steps ahead than your contemporary friends and students. So n different things to be distributed among different groups are different groups. Are different groups in r to the power 1 ways. That is total distribution where blank can allowed in anywhere. Now I am letting that let AI denotes the distribution. AI denotes the set of distribution, where ith group means GI. Here GI, ith group ith group remains empty, remains empty. ith group remain NC. In that case, total number of distribution will be what? Where one group, ith group means one group. That concept I already explained you. See, if one group is dropped, then total number of distribution 4 minus 1 to the power 5. Here r minus 1 to the power n. Okay, if one group is dropped as it contains empty space. Okay, okay, got it? Why it is reduced by 1? The all I groups, you know, these groups, all in each case the emptiness could have come, each case. Now one group is dropped, then r minus 1 to the power n, ith group remains empty. Now I will consider, must tell me if you find any difficulties. Two sets I am involving, AI intersection AJ denotes the set of distribution, the set of distribution AI intersection AJ. Here actually ith group get no object. Ith group matter is same, gets no object. Now AI intersection AJ denotes what? Means two places will have no object, remain empty. AI intersection AJ denotes the set of distribution where ith and jth group get no objects. Then two places will be dropped as we have dropped before. Okay, 4 minus 2 to the power 5, few minutes back we got two things, there will be no places, no object will be inserted there. Yes or no? So same concept we are generalizing. In that case, then total distribution in AI intersection AJ is r minus 2 to the power n, r minus 2 to the power n. Now if I introduce another group of same type, you observe in AI AJ AK, AI AJ AK denotes the distribution. This thing demands your patience. Denotes the distribution where I, J and kth group get no objects, no things. In that case, total distribution r minus 3 whole to the power n. So we will keep on, dropping the place from r. and and our observation will be on. But what is the theory so to be discussed? See, n different things to be distributed in r different groups where blanks not allowed, and here we are calculating where blanks allowed. Means each group, if one group is not getting an object, that means I am accepting the blank space in lieu of that. Yes or no? So whatever distribution I'll get, I have to take its complement. Complement means reverse. Yes or no? So n different things to be distributed in n different things to be distributed in r different groups. If blanks not allowed, then total distribution of such type, will that be like that? No, it's complement. N A1 complement A2 complement, because A1, A2, A3 accepting the blank space, so its complement will rejecting the blank space. A3 up to AR. So by De Morgan's law, I have just told you when I persuaded this, you see, complement, it will become union whole complement. So that concept to be used here, it will become union. Now the recurrence formula will give us what? N of S. What is N of S? N of S is that r to the power n. N of S is total distribution minus summation of NAI minus summation of NAIAK. These are you are counting these now. Plus recurrence formula AI intersection AJ intersection AK and so on. NS is what? R to the power n. NAI C r minus 1 whole to the power n. Yes or no? But there is a question. What question? That I will be chosen for emptiness, but which I? There are r number of elements. You have to choose one particular I. In how many ways? Had this been first one, RC1, had this been first to RC2, so one element has to be chosen. Yes or no? Hello. If you have any doubt, without any hesitation, you can ask. Yes. Again, obviously, the question is, in different things to be distributed in r different groups, if blank space are not allowed, then total number of ways of arrangement. We are pursuing in what manner? That group means, say, in a school, there are 5 sections in a class. Section A, B, C, D. So these are groups G1, G2, G3, GR, GI. Now, in different things, I am choosing, and here blank not allowed. Obviously, in a school, your teacher will expect that no places should remain empty in a bench. That means blanks should not be allowed. But here we will calculating allowing the blank. I will consider, okay, in these days students always will not come to school. They will sit at home and prepare for JEE. Okay, so I will consider that one place remains empty. तो क्या है AI एक ये जो R नंबर ऑफ प्लेस है इसमें एक नंबर हम ले लिया AI denotes क्या set of distribution where ith group is empty. One place ith group is empty. If ith group is empty, then total number of arrangement क्या होगा? एक तो कम हो गया r-1 to the power n. Now I will consider AI intersection AJ denotes the distribution where I and J, two places will have no objects, means they will remain empty. Then distribution क्या होगा? और एक कम हो गया r-2 whole to the power n. ठीक है? Then I will choose another set AI, AJ, AK denote the distribution of 3 I, J and kth group remain no objects, contain no objects. So in that case distribution is 3 r-3 whole to the power n. In this way I will keep on increasing the case, and at the end what is told to find? See, n different things to be distributed in r different groups in blank. If blanks not allowed, then total distribution is such type is what? You see here, whatever we are getting in AI intersection AJ intersection AK where blanks allowed, तो नॉट अलाउड क्या होगा? तुम तो सेट थ्योरी किया है. अगर ये अलाउइंग का केस है, नॉट अलाउइंग होगा AI complement, AJ complement, AK complement. So total number of permutation in that case will be कितना ग्रुप है? R number of group, A1 complement, intersection A2 complement, intersection A3 complement, intersection AR complement. So in set theory, by De Morgan's law, you are taught what? In class, even in junior class, see, A complement intersection B complement is nothing but A union B whole complement. तो यहाँ पे 2 सेट इन्वॉल्व है, यहाँ पे R नंबर ऑफ सेट इन्वॉल्व है, बट वो रूल तो सेम ही रहेगा. तो A union A2, A union A3 up to AR whole complement आएगा. I forgot to put that superscript C. Now n, any complement is what? N of universal set minus Na. So n of this thing complement is what? Ns minus this, the full thing. So instead of this, what can I write? See, for 2 set n A union B, you are writing what? N A plus NB. What is here? Where is Na plus NB? This summation. N here n R numbers are there. N A1 plus A2 up to AR minus in A intersection B. In junior class you were taught. It means the sets are in pair. Here R number of pair A1 AJ means A1 A2 A2 A3. So again then you have to add in rhythmical way in A1 AJ AK. So the series will be on. Now this A1 is chosen in what manner? A1 is one place which will remain empty. कितना प्लेस था R, एक प्लेस चूज करना है तो ये इसको बोल RC1 वन प्लेस आउट ऑफ R. n AI क्या है? R minus 1 whole to the power n. Now two element चूज करना है RC2 R minus 2 whole to the power n. Now three element चूज करना है RC3 R minus 3 whole to the power n and so on. Now remove the bracket. This is the property for pure J preparation. If I remove the bracket, this will be plus. Again, this will be minus and so on. So this is the theorem where there is expansion. Binomial you are not taught yet. You can compare it to exponential or binomial expansion. So this is the theorem where n different things to be distributed in R different groups. If blank not allowed. Okay.